Here we are with example 2, hypothesis testing involving a proportion, percentages. All right, so a recent study claimed that more than 37% of all traffic fatalities are alcohol related. More than 37% of all traffic fatalities. So I would point out that that's a claim being made about a population, all traffic fatalities, and therefore the parameter involved is P, the percentage of all traffic fatalities that involve alcohol. If you go back and look at the labels here, more than 37%, that would be a greater than type of statement. So the original statement made by that study is that the percentage of all traffic fatalities that involve alcohol is greater than 37%. So it turns out that in this example, the original claim is the alternative, the so-called recent study. Let me take you back to the question so you can see that again. And again, keep these questions in front of you as we walk through them. But that's what should jump out at you, more than 37%. That's an example of an alternative type of hypothesis. So we're basically on this one going to put the burden of proof on that study to prove that that's the case. So the corresponding null would be to assume that it's equal to 37. Now, honestly, the exact opposite is less than or equal, but it'll work for us to just label it as equal. I know there are some books that would call that less than or equal. Equal is going to work, all right? It's worked for many people before you, so there's the deal. So that study made it a greater than type of claim about a percentage of a population, and there's your alternative. The test statistic we mentioned will stay the same on every one of these. You can write that down in ink on every question on this assignment. It's going to change when we'll move to a mean. It'll be a different deal. All right, so our rejection region. Z, look at here, Z, right? So Z, that'll be our standard normal bell curve here again. And the level of significance they want us to use, alpha, is 2.5%. So I always want to remind you that the 2.5% is how much of the bell curve we're essentially giving to the alternative hypothesis. Again, innocent until proven otherwise. The burden of proof falls on the prosecution. The burden of proof falls on the alternative. So you look at that and you say greater. Oh, okay. This will go on the greater than side. We're essentially going to put that 2.5% in the upper tail. And I noticed that my pet word right now is essentially, it seems. But I want to remind you again that if your alternative hypothesis involves greater, you're going to put that alpha in the upper tail. And that's I don't know if you can see the colors, but the alternative is red, the alpha is red, that's red, those all connect. Okay? So basically, if you look at this picture, we're giving the vast majority of the bell curve to the null hypothesis, just like you give the presumption of innocence to a defendant in a court case. That's the analogy most people will give. All right, but the deal is we need to find that z-score that lives right there. It's basically the cutoff statistically between innocence and guilt of that null hypothesis. So, much like we've been doing for a long time, and I have to hope that the mechanics of this are now very familiar to you, this is all 50%. We don't need that. We need that middle sliver. So wouldn't we take the upper half of the bell curve, 50%, subtract that 2.5% to get the middle sliver, which is 47.5%. So I have to hope that finding these middle slivers is now a formality. All right? So upper half of the bell curve, 0.5, minus tail, middle sliver, 4750. And in the body of this table, 4750 lines up with 1.96. We have done that so many times that I'm hopeful by now this is just second nature to you. 1.96. So, I left this up here. Reject the null hypothesis if the following happens. When we go stick numbers into this thing and get a z-score, see, we're setting the rules of the game before we go and collect evidence, p hat, percentage from a sample. When we plug numbers into this, we're going to get a z-score, and you know what? We're going to reject that null hypothesis if that value of z lands above, greater than, the 1.96. So again, it all connects back. If your alternative is greater, you're going to put that alpha on the greater than side, and your rejection would be on the greater. Okay, so if we get a z-score here in a second, when we go collect data, collect evidence, just like, going to trial here, if we get a z-score greater than 1.96, we're going to reject this in favor of this. That's the idea. Okay, so a researcher goes, and this is where in a sample of 250, 113 involved alcohol. All right, so in a sample of 250, 113 involved alcohol. 113 out of 250. 113 out of 250 is 0.452, and that's obviously higher than 37%. But a statistician doesn't just look at the results of one sample and make the leap. See, this is comparing what we observed to every sample we could possibly take. It's a very theoretical thing, but we want to see if the difference between what we observed and what we're assuming is what they call statistically significant. And significant is to be more than 1.96 standard deviations away. All right, so there's a lot of theory there. If you can do the mechanics here, you're in good shape. So now we do the compute part of this. So we'll say, all right, this is like we're going to trial here. We collected evidence. We observed 45.2% minus the 0.37. See the difference. P hat is what you observed in your sample. P is what you're assuming would be the percentage for your whole population. P would be 37, Q would be 1 minus that, which is 63%, so that's 0.37, 0.63. I know I'm talking fast, hit pause, but remember P and Q are complements of each other. And so I took 1 minus 0.37 to get the 0.63. Maybe I should write that on the board, I don't know. And anyway, hit pause, go push buttons, whatever. Peek and look at the next slide, but this is where you crunch these numbers out. And you will see if you peek, that and if we were together, what I usually do is I write this number on the board, and I cover it up, and I let you guys crunch for a minute, and then I push that aside, and we see if we get the same thing. But it's kind of anticlimactic here, because if you peek ahead, you'll see in the next slide that it's 2.685. So either don't peek or hit pause, go crunch it yourself, all right? But 2.685 should be the observed value of Z here. And so now we come over here and we go, where does that fall? Remember, these numbers across the bottom of the bell curve are Z-scores, and you'd hopefully say 2.685 is out there. 2.685 is indeed out there beyond the 1.96. It's also greater than 1.96. Now you said if you got a z-score greater than 1.96, you were going to reject the hoe, weren't you? All right, so the point is, you would say, hey, null hypothesis, I gave you the majority of the bell curve, but my observation took me outside of that area. I reject you. This would favor, didn't we land in that upper tail, and that upper tail was the region we were given to the alternative, weren't we? Okay, so who won? The alternative hypothesis. When we formulate, so our decision would indeed be to reject the null hypothesis, reject it, right? We assumed it was true, but there was indeed enough evidence beyond reasonable doubt, court case, to reject it. We got a conviction of the hoe. So, what's that mean? I would always tell somebody to use the wording of the question to answer the question. It was from the point of view, it says, is there evidence to support the study's claim? I want to remind you that the study was making the claim, the alternate claim, wasn't it? That's why it's important at the beginning to label this. The study said that it was greater than 37%, and there was evidence to support that. So we should write our answer up accordingly. And so if, again, you look at the printout you have, the PDF, or if you're able to read it on the screen there, I would say, at the 2% level of significance, there is enough evidence to support the study's claim. The study made the alternate claim, and there was evidence to support that. So, it depends on the point of view of the question as to how you answer it. So I will again tell you, use the question itself to formulate your answer. And that's important. It's important that you write it up. And I would invite you to look at the question and compare the wording of it to our answer. They're very similar. In fact, when I made these slides, I copied the question and pasted it there, and then formulated my answer accordingly. So there you go with that. There was enough evidence to reject the null hypothesis in this case. So, all right. What's he doing here? Yeah, I got something for you for rejection. Here we go.
Plus their guard play is so much strong. They can basically
That's
go
not very
950 and not lose anything.
You can't see the video. That stinks. Let me try it again.
Plus their guard play.
I don't know why that happened.
Strong. They can basically.
That was kind of anticlimactic because it says, I'm not sure what happened to that file. Anyway, oh well. We'll see if it works on another one later. All right. Good luck.